Welcome to June 9th LeetCode Challenge, Jumping Game 6. You're given a zero-index integer array nums and integer k. You're initially standing on index 0, and in one move, you can jump at most k steps forward without going outside the boundaries of the array. That is, you can jump from index I to any index within the range of I plus 1, minimum of n minus 1, k plus I plus k inclusive. You want to reach the last index of the array, index n minus 1. The score is the sum of all the nums at index j. For each index j you visited in the array, return the maximum score you can get. So let's go for an example of this here. You start at index 0, which is 1. You would jump within k number of distances, so you can either jump here or here. So if you choose to jump on -1, you get negative. Now you have 1, -1, which is 0. Then you jump on 4. Now you have 4. Then you jump on 3 here. Now you have 7, which is the maximum number of stores you can get by jumping from index 0 all the way to the n within k numbers of jump. So you want to turn the maximum score of that. Let's go for another example here. Start at index 0, which is 1. If you were to jump on, let's say, within you have a maximum of k numbers of jump, which is 2. So if you were to jump on -5, you would have -1 in total now. And then you jump on, you would jump on, no, you have -4. If you were to jump on -5 here, then you would jump on 4, which means you have 0 now. And if you were to jump on 3, you would have 3. And then you would jump on -3 again, which is now equal to the output of 0. So this is a classic dynamic programming question. I think the best way to approach this would be to use a some sort of heap or queue in order to keep track of the numbers you've jumped on before, so that you could minimize the space complexity. So you're probably going to use a double-ended queue or a deck. So let's kind of define our deck here. So D is assigned to deck, and then from that we want to append 0 to the very beginning, because that's when we start off our at index 0. We have 0 numbers of jump so far, and then we want to define a dynamic program array. So let's say that we want to define an array of size, let me see, 0. So you want the size, the length of n, or length of nums, I should say. And then you want to, for the index 0 of the dynamic program array, you want to assign that to be the first number of your nums array, because we start off at index 0 for the jumps. So now, naively, you could go through each numbers of jump and store it into your dynamic program array. However, if we have a double-ended queue here, we just keep on storing the maximum number of scores we can get from it. So we're going to loop through each element in the within our nums array. So for I in range, starting from 1 to the length of nums, what we want to do is we want to change the index of our dynamic program array, index I. We want to assign that to be the score that we get from our jumps, the possible score, or candidate score. So it would be the D at 0 plus the number that at index I. So we're storing the score that we get from our possible jump. And then if our Q at index 0 is equal to I minus K, so this is what we want to let's see. So if our double-ended Q at index 0 is equal to I minus K, so if that happens, we want to remove from the left of the index with you want to pop from the left side of the double-ended queue. So deck.pop left. So you want to move the index on the left side of the double-ended queue. So while the double-ended queue is not empty, and the double dynamic program array is we want to take a look at the last element of our queue, and then we want, if that's less than what we have at index I. Remember, try to store the largest amount. If it's not the highest score we can get, then what we want to do is pop it from the double-ended queue. However, if it is the highest number we can get, we want to append that to our queue. So append index I. So at the end of all this, we want to return the last or highest value of the scores we can get that we've stored as we go along each element in our nums array. So this is equivalent to returning the dynamic program array at the last looking at the last element we put in it, because it is the highest score we can get. So this is kind of utilizing a like a sliding window type approach to it as well. Let's just run this code, see if it works. Okay, that looks fair. Let's submit it. Awesome, accepted. So time complexity wise, we have we cycle through each element in a nums array, so it would be n times log k, big O n times log k for time complexity. And for space complexity, since we have a double-ended queue that's using a sliding window type of property to it, we're only storing k memory space, because that's the number of jumps we could take, and we're storing the highest amount of jumps we could take per I value. So the space complexity big O of k. It's a nice one to study for dynamic programming, because it's really the jump series in general. Let's look at some of the hints here. So yeah, this is the let the dynamic program at index I be the maximum score, starting at each ending start at index I. Answer is, here's the answer. So this is the kind of the naive approach here, where we store each jump and for each element in the nums array. But since we have a double-ended queue, we cut that down to the log, so big O of n times log k instead. Yeah, instead of checking for every jump, keep track of at the heap location. Yeah. So instead of using the heap that's suggested here, we use a double-ended queue, which either way would work, I would suppose. But otherwise, that's it. Have a nice day.